write 1 here and your mesh, your starting mesh is huge, like if you're gonna run the North Atlantic Comprehensive Study mesh and it has 3.1 million nodes, and you're gonna do the same size subdomain that I just pulled, same circle, you're gonna have not 121 nodes in there, but you're probably gonna have like, guess, I don't know, maybe 200,000 nodes in there or something. It's way more. So if I write 1 here, it's gonna take forever. Don't write 1. Write 100. 100. If you read their paper, they show that 100 is a suitable number. You get very, very accurate results using this value, and you won't waste your time.
Could you explain again what that value is?
The value is how often you're going to record from the full domain run information at your boundary nodes for your subdomain.
So why is, so a higher number means more often, right?
Time steps?
It's a time.
Oh, okay.
Yeah, every 100
I see,
seconds.
okay.
So if it's more, you're getting the force every second.
Yeah, I guess I should say how often. It's the time increment. Yeah. Okay.
And
So sorry.
You were running 20 seconds or something?
Sorry?
In the Fort 15, you were running 20 seconds.
20 seconds,
or something,
exactly,
So it'd
yeah.
be every 2,000,
It's every 100 seconds.
every seconds.
Every 100 seconds. Okay, it's asking me now, are you specifying predetermined subdomains, yes or no? Yes, I am. The no option, which is an option, you can create boundary conditions at every node in your mesh so that you can pull a subdomain out after the fact. Instead of having to run, like let's say I don't like my subdomain. I wanted to do lower bay, but now I want to look at the upper bay too. So I would have, if I write yes here, I'm gonna have to go back, rerun the whole full domain run with a new subdomain in there. Does that make sense? If I say no, then it's gonna record everywhere. Also will take forever, right? If I have a big mesh, because it's gonna assume there's boundary conditions everywhere that are needed. So something to keep in mind. But yes, in this case, I'm telling it where the subdomains are. Where is the subdomain? The subdomain is back 1. It's called sub. That's my directory. And again, if I were to just give it this without the slash, it would yell at me. So I give it the slash because it's a Python script. It's asking me again, enter the directory of the next subdomain, but I have none, so I write done. Okay. So it's ready. And this is what it looks like, okay? It's saying there are 19 boundary conditions that are needed. These are the values of the nodes. You gave me this value for n spool. So we're good, it looks good. Okay, so now we're ready to run a full domain run. So this is as usual. I mean, nothing is different now. This is my job 2 file. I did this earlier today and I used 256 cores. I'm not going to do it now because actually I was in the queue for a long time. But with 256 cores, this took about 8 minutes, I think. But with like the same settings that I just applied, the same time step, everything, okay?
Jenna, what was your time on that?
Sorry? How long did the run take?
No, for job.
Oh, I told it, I think 20 minutes.
Oh, yeah.
I just knew that it would take less than 20 minutes with this number of cores. Okay. So, what else? Okay. These are the results. I ran this thing as you normally do. I've got max Ellie's, and I have a 61, but it's empty, right? There's nothing there because I didn't ask for any recording stations. So now I can run the subdomain run. And I did one already, but I guess that what we'll do is run it again because yeah. Okay. I'm just gonna take all this stuff from before my run. And all I'm gonna do is copy it back to a new folder and rerun with you guys so that you see what the process is. All that's really left at this point is to go back to the full run and extract the information that I need at the boundary conditions. So I'm going to run gen bcs pi. It's going to create a file called fort019. It's going to go back, pull out the information that it needs at all the boundary condition nodes, and create this fort019 file that I need. I'm going to take everything except that. So you notice that I put ADCIRC in here. ADCIRC is in here too, but I'm not going to use it. Why?
Because we don't need to divide our mission, like, already we're using one subdomain.
Yeah, well, sort of. In this instance, my subdomain has 121 nodes in it. I don't need to run in parallel on
Yeah.
121 cores. I can run the serial version of ADCIRC. In fact, I'm pretty sure that if you tried to run that small of a job in parallel, it wouldn't let you. Because in order to do that, you have to run ADC prep first and prep your mesh and split your mesh, and I think there's a minimum number of nodes that need to go. Do you think that's right, Celso?
Sure, it becomes inefficient.
Yeah,
I'm not sure
I don't
why.
think it will even let you do it. I think ADC prep will crash on you. Anyway, so that's what I'm intending to do. So, but for now, I'm gonna run gen bcs pi. I'm in my full directory, so I'm gonna go back to my subdirectory. And, oh, that's not what I called it this time. Subclass. Okay. I really like, Seth hates when I repeat this a million times, but I really like the LL command because I can see really quickly if these are executable or not. If they're green, they're good. If they're not, they're not. So yeah, if I do that again, they're all good. So I'm in here, so I'm gonna run Python back one gen bcs.py. So the stuff you need to tell it here is is your full directory? It's back one, it's called full. Where is your subdomain directory? It's where I am. This value, I can't remember what it's for. There's another set of options here, 1 or 2. Go back to the user guide for this, I can't remember. I'll tell you when we go back to the lab, but what you need to know is that option 2 is not yet developed. You need to do option 1. And then this other value, SBT, IM, whatever, that has to be a multiple of the N schools GS value that you chose. I chose 100. I'm gonna put 100 here. What this is how often you now want to sample your full domain output files to your boundary conditions file. So I'm gonna put 100. Am I gonna run, did I run in serial or parallel? I ran in parallel. So it's reading the 414, and this should really not take very long. And it's done, okay. Okay, so now, I'm ready to run this, okay? The way that you run this in serial is like this. This has to say 16. There are 16 MPI tasks per computer. I want to run on one node, so 16 processors per node. I'm running on one node, so 16. And then down here, I'm telling it to run not ADCIRC, but ADCIRC. Now obviously you have to make sure that ADCIRC is in that folder, right? It's right here. And then you don't have to run ADC prep because you're not separating your mesh, right? So all you're running is that one job 2.2 file. Do not type ADCIRC in here and run because Stampede will get very upset with you. You don't want to do that. You don't want to run things on the node. Right now I'm on a node, and that's what this window is. I'm on a node on the supercomputer. I don't want to run there. I want to run from my submitted, I want to submit a job essentially. So that's what I'm going to do. So it goes, I submit, it takes maybe a minute, and then everything will, once the job goes through, it takes a minute, which really shouldn't take that long, and then you'll get the same thing. You'll get max LEs and all that. So the next thing you want to do